This is a video for AQA Discrete Mathematics, Linear Programming Section 2.4, which looks at performing iterations on the simplex tableau. We've seen how the initial tableau is set up using the linear program and equations using the slack variables S1, S2 and S3. This initial tableau actually represents the position at the origin, where x is equal to 0 and y is equal to 0. The top row of the tableau is the objective function, and at the moment you can see here in its value we have the objective function equal to 0. So clearly we could make some improvements, and that's indicated by the fact that the coefficients for x and y are negative values, negative 10 and negative 9. We start off by choosing the most negative value, so in this case negative 10, and refer to the column which contains the most negative value as being the pivot column. What we're now going to do is decide, well, how much can we change the value of x by to increase the objective function. There's a test to do that, sometimes known as the ratio test, which says take the numbers in the rows below the objective row and divide them by the corresponding numbers in the pivot column. So 12 divided by 1 is equal to 12. 30 divided by 2 is 15. And 20 divided by 2 is 10. Then we choose the smallest positive value of those. In this case, 10. And that then produces this element here as being the pivot element. So 2, which is in the pivot column, and in the smallest positive value from the test gives us the pivot element. Now if we look at the graph for a second, those numbers that come up in the test are these intersections. First one there is at 15. This one here is 12, this one is 10. So you can see why we must take the smallest positive value. What's going to happen is the simplex method is going to move this point away from the origin, but it must stay within the feasible region, hence the smallest value. So just running through that quickly again, we look at the most negative value in the top row, which gives us the pivot column, and then divide the numbers in the final column by the corresponding numbers in that pivot column. So 12 divided by 1 is 12, 30 divided by 2 is 15, 20 divided by 2 is 10. Then choose the smallest positive value to give it the pivot element. We now want to use what are called row operations to make this column for x equal to 0, 0, 0, 1. So we're going to make this equal to a 1 by firstly dividing this row here by 2. So if I can say that this is row 1, row 2, row 3 and row 4, and I'm going to get row 5, row 6, row 7 and row 8 in my table, then row 8 is going to be equal to row 4 divided by 2. So it becomes 0, 1, 0.5. You might want to use fractions, sometimes easier, but 0, 0, 0.5 and 10. We can now use this row 8 to add to rows 1, 2 and 3 in turn. So let's first of all consider what we need to add to row 1. Well, at the moment it's negative 10, so if we add 10 lots of row 8 to that, then that is going to produce the 0 that we require here. So row 5 is going to be equal to row 1 plus 10 row 8. Now that's obviously not going to change the first element there. The second one is 0, negative 10 plus 10. We've then got negative 9 plus 10 times 0.5, which is 5. So that gives us then negative 4. The next one is 0 plus 0, which is 0. And then also 0 plus 0, 0. Then in the S3 column, we've got 0 plus 10 multiplied by 0.5, which gives 5. And then finally, in the final column, we've got 0 plus 10 multiplied by 10, which is 100. The next row, row 2, has got a 1 in the pivot column, so we need to subtract one lot of row 8. So row 6 will be row 2 minus row 8. And that produces 0, 0, then 0.5, 1, 0, and negative 0.5. And the final one will be 12 minus 10, which is 2. Lastly, consider row 3, which has got a 2 here. So that we can do is row 3 minus 2 lots of row 8. So row 7 will be row 3 minus 2 times row 8. So we end up with 0, 0, 2, 0, 1, negative 1, and then 30 take away 20 is 10. So those are the row operations there written out. Remember that we first of all started off by dividing row 4 by 2 to make sure that we got a 1 here, and then added or subtracted multiples of that row to each of rows 1, 2 and 3 in turn. I suggest you then pause the video at this stage and just take a little bit of time making sure you understand those row operations. That completes the first iteration, but we can see now that we've still got a negative value in the objective row. So we need to now do exactly the same thing again. We now have a new pivot column, so we take these values here and divide them by the elements in the pivot column. 2 divided by 0.5 is equal to 4. Have 10 divided by 2 is equal to 5, and 10 divided by 0.5 is equal to 20. The smallest value, which is positive, is 4, which means that our pivot is going to be 0.5. Again, just checking those values 4, 5 and 20. This time we're changing y, so we're moving the y value upwards, but we must stop at the first one we get to here, which is at y is equal to 4. the next value is that intersection which is outside the feasible region, y equals 5, and there would be another one which is way off the graph up there, which is at y is equal to 20. So the smallest positive value is going to lead us to this point here. Now we must use row operations to make this pivot column have the values 0, 1, 0, 0. So the first thing we do is take the row which contains the element and divide it by 0.5 to give 0, 0, 1, 2, 0, negative 1, 4. So that was done by taking row 10 to be equal to row 6 divided by 0.5. We've now got a 1 in row 10, so it becomes easy to do our row operations to work out rows 9, 11 and 12. Row 9 we need to add 4 lots to row 5, so row 9 will be row 5 plus 4 times row 10. If you look at row 7, there's a 2 there, so we need to subtract. To get row 11, we're going to take row 7 minus 2 lots of row 10. And finally, we've got 0.5 here. So to get row 12, we're going to take row 8 and subtract half of row 10. So again, using that new pivot with row 10 to calculate our values for the new rows. What I suggest again is that you pause the video here and check that you get the value on the next slide. So here's our completed table, and we can now see we've got all positive values. So that means then we must have found our optimal. We'll look at how we interpret the tableau and what that means at the final values in the next video. But to go through this process again, remember that we, having formulated the problem as a tableau using the slack variables, we find the pivot column which has got the most negative value in the objective row. We perform the ratio test, and for the ratio test we take the element which has got the smallest positive value. That gives us a pivot element, and then we work out that new column to have 0, 0 and 1 in the appropriate place, and then all of the new rows are produced by using the row operations. We keep repeating that process until all of the elements in the top row are non-negative. That concludes this video, and in the next one we'll look at how we interpret that final solution.